Okay, read the question. A train crosses a station P with speed 20 meter per second and whistles a short pulse of natural frequency f naught 1570 Hz at t equal to 0. Another train B is approaching towards the same station with retardation 8 meter per second square along a parallel track. These are the tracks. The two tracks are 99 meter apart. When train A whistles at station P, train B is 140 meter away from the line PD and listen the pulse at t equal to 0.5 seconds. If the velocity of sound in air is 330 meter per second, calculate the frequency of the pulse heard by the driver of train B. Find the initial velocity of train B. And is asking to get the cos theta also. I'll put the total diagram. These are the tracks. These are the two tracks. The train A is here. And the train B is here. Just some picture information, so that it will be easy for you to imagine. That's why I brought like this. Now, what is this? This should have some initial velocity train B because it will undergo retardation. And train A crosses. This will cross with a speed how much? UA 20 meter per second. We'll write all the things, the data. Okay, this distance is what? 140 meter. This is at t equal to 0. This is at t equals 0. Now a pulse will be generated. Please try to understand. It's very easy, just based on kinematics, nothing. No need to get scared, just based on kinematics. This is theta, let me take it. There's a point A, there's a station P. This is the distance D, and this was at B and at C. So when the train arrives at B, it is going to hear that pulse. So it is undergoing retardation. So what do you expect the train definitely when it arrives here? What is the state of train A? Train B, it was undergoing retardation, no? So it will have some velocity, say VB, when it is hearing that pulse. And this happens at what time? 0.5 seconds. Where the train A will be somewhere here. We are not bothered its position. It crosses, I don't know what is the velocity of that, everything, no information is available. This is at t equal to 0. Here the pulse is generated, the pulse will be detected. The pulse will arrive here. This distance, what we know is 99 meter. Straight away, what is the Doppler effect formula? What is the speed of the train A when it generated pulse? Pulse is generated here. At P, pulse generated. At C, pulse is detected. What is the Doppler effect formula? First, we'll write Doppler effect formula. We'll come to know what to do. F dash is equal to speed of the wave, speed of the sound wave. It is V. then source is approaching the observer, no, along that one. So, so detector is approaching it. So this will be V plus VB cos theta, uh, VB sin theta, no, cos theta only. This will be cos theta, no, this angle will be cos theta. I'll put it, yeah, VB cos theta, F divided by V, and the component of velocity of this is source. So in simplest thing, this is source and this is detector. So this will be V minus UA cos theta. Tell me, like, what all we know? We know UA, we know speed of the sound, we know F, we don't know theta and VB. Am I right? What is VB? Velocity of the train B at the instant when signal is detected. Got the idea? So VB and theta are known. Let's see how we can find out. We know retardation. We know retardation. So what is this? Let's get into the discussion. So this distance, how much it will be? Say some x. What is x is equal to? See, by the time train B moves from B to C, what will happen to pulse? Pulse will move from P to C. Are you able to understand? So what is this? This is a path of the pulse or propagation distance. So what is PC? PC is a propagation distance. Shall we use word? Propagation distance. By the time pulse moves from P to C, the train will move from B to C. Got the idea? So what is X? I should write now. What is X is equal to? X should be equal to UB time taken 0.5 or T, let me write T minus AB or A T square by 2. There's a distance moved by the train B. In that interval of time, this particular wave will cover a distance PC. So what is that distance PC? I should write here. Speed of the wave into this time. Do we know speed of the wave? 330. Okay, I agree this. Then do we know time? Time is how much? 1 by 2 or 0.5. This will be how much? Anybody? 330. 175. Okay, somehow I got the distance PC. If you know distance PC and you know PD, can you bring the sine theta value? Sine theta is equal to PD by PC. 99 by 175. If you know sine theta, can you bring cos theta? Okay, I'll get the cos theta. 165. This is still. I want the velocity of train B. How to calculate velocity of train B? For that, what is needed? VB equal to we don't know that initial velocity of train B also. We know A and T. We don't know X and T. After getting this cos theta, or after getting this cos theta, can we get distance CD? So what is the distance CD? 140 minus C, no? So cos theta, what you can write it as? CD by PC. So what is distance CD is equal to? PC cos theta. What is the distance PC? Oh, so sorry, what is the PC? We know it. PC 165. What is the distance CD? 140 minus 6. So now I'll substitute all the things. 140 minus, what is x is equal to? UBT, UBT minus ABT square equal to 165 cos theta. We know value of cos theta. We know value of cos theta. If you know cos theta, then what when we'll get the x. That I think, okay, then after getting x, you know t, you'll get ub. You can work out in either way. Huh? So we know cos theta from here. We know sin theta, will get cos theta. After getting cos, substitute here. You know ub and you know t and ab. So this is a, no. I'll substitute all. T is how much? 1 by 2, no? So this will be ub by 2. A is how much? Retardation 8. 8 by 2, 1 by 2 whole square, plus it will be 165 cos theta. Substitute the value of cos theta from here, you'll get that initial velocity. After getting this initial velocity, what is needed? We needed Vb. How to bring Vb? Vb is equal to ub minus a into t. A is how much? 8. This is 1 by 2. So ub minus 4. I'll get the value of Vb. That I'm going to substitute. I'll get the apparent frequency. Okay, fine. Very good problem. Just kinematics is what is troubling you. Doppler effect is only a small idea. Finish over here. You can expect questions of these kind in the Doppler effect. Cos theta will be 0.8. Check it. Cos theta will be 0.8.